SQL injection, blind SQL injection boolean based. So we finished with the blind SQLi authentication bypass, and that was really interesting. Now we proceed with task 7 and 8, 9, 10, maybe not in this video, depending on how much time it takes to actually get through them. Comment down below and let me know if there is any background noise. Also, comment down below with your thoughts on these videos, which are walkthroughs through these rooms on SQL injection and the rest of the things that the rest of the rooms that are very relatable or related to penetration testing, plus my perspective. So this is the caveat. I'm doing these videos because I'm not because I want to fill the internet with more spam on doing the same videos as everyone else, because there probably are tons of videos that have gone through these rooms walkthroughs, but the caveat here is that I'm going to add my own twist from my own experience, so as a penetration tester, which when it comes to SQL injection is not the best, but hey, we all have to learn. Boolean based SQLi refers to the response we receive back from our injection attempts, which could be true, false, yes, no, on, off, 1, 0, or anything of that matter. Any response which can only ever have two outcomes. So blind SQLi. On the first, so the outcome confirms to us that our SQL injection payload was either successful or not. On the first inspection, you may feel like this limited response can't provide much information. Still, in fact, with just these two responses, it's actually possible to entirely dump a database of a certain application. On level 3 of the SQLi example machine, you are presented with a mock browser with the following URL. The browser body contains the content taken true. This API endpoint replicates a common feature found in many sign-up forms, which checks whether a user has already been registered to prompt the user to choose a different username. Because the taken value, which is this one, is set to true, we can assume the username admin is already registered. Why? Yes, that's why. In fact, we can confirm this by changing the username to, and upon pressing enter, you'll see the value taken. Let's actually fire up a Firefox here. SQL Injection v2. I think we've gone through these ones, right? So do we need to actually go through them one more time? Website.thm. Let's see in the attack box if we can do. This is an HTTPS. Website.thm. I'm still not very good with this platform. The hell? Alright, so it's probably in here, right? Very likely. So in this situation, Martin's password was $VORD. Sort of, I guess. Username was, what was the username? Can't remember exactly. Probably might have to check out the previous video. So we did, or 1 equals 1. Log in. Level 3. Right, so we had to complete those just to get to this one. I have to keep this in mind for future future videos if I'm not gonna finish this one here. This is what we deal with if we change the admin to admin 1 to 3 and then we hit enter, taken false. Now, the SQL query that is processed looks like the following. Select everything from where username equals whatever username is in the username parameter here. Limit 1. We only need one response. As the only input we have control over is the username in the query string, we'll have to use this to perform our SQLi. Keep the username admin as admin123. We can start appending to this to try to make the database confirm true things. Admin123, then union select 1 semicolon comment taken false. So let's keep on adding columns as they say here. 2 3 is gonna be true, then union select 1 2 3. We need to add where database, so in this case we're gonna see maybe database, so in this case we're trying to guess the database name. We get a true response. This is actually starts with, I believe, where database like percent, like that, it's true, which will match anything as it's the wildcard. So percent is the wildcard in SQL. If we change the wildcard operator to A, it starts with A and then it continues with anything. So we know that if this is false, which is in this case exactly what it is, the database doesn't start with, the database name doesn't begin with the letter A. We can cycle through all the letters. Now, fellas, in this situation, it is when your programming skills come into place. So if you know how to code, you'd be able to put up a Python script very fast that will actually be tailored to your own situation here. So instead of you just having to input A, B, C, D all the way through the entire alphabet here, you could just run a script, actually run a loop in which you're scrolling through all of the letters of the alphabet and looking for changes in the response. That would be quite easy to code in Python. This is why it's really important to have some programming skills, because if you're just a penetration testing, a bare bone penetration testing with no other skills, and you're just using other people's as tools, then your skill set is very limited, and chances are you might be likely very truthfully be called a script kiddie. We can cycle through the letters, numbers, and characters such as hyphen and underscore until we discover a match. If you send a below as the username value, receive a true because that confirms the database begins with the letter S. So let's imagine that we've used our Python script and the script has looped all the way through S, and then we get it starts with through S. Let's say the next one is A, and we keep on B, C, D all the way up through. What if we do SQLi? It's also true, so the actual is SQLi3. We established the database name, which we can now use to enumerate the table's names. So when you actually establish SQLi underscore 3 and then you remove this wildcard, you actually, so if we do 3, we get the false. You've actually found the database name. Once you found the database name you want to enumerate for tables, and you're going to be using the information schema which contains the logistics of the entire database, or the configuration of the entire database, or the blueprint, so to speak, the very abstract blueprint of the entire database. So in this case, you're looking for information schema, and most specifically for tables. Well, where table schema, actually, we're looking in the schema of SQLite 3, which is our database. So we very specifically look in the SQLite 3 database via the information schema.tables for the table name that starts with this. And in this situation, you're actually going to enumerate so on and so forth. So let's actually type that in, and then we'll flash forward through the rest of them. So union select 1, 2, 3. 1, 2, 3, you're selecting from information, and notice that this is not case sensitive. Information schema dot tables, where table schema equals SQLite, let's do this in double quotes, SQLite 3, and table name, notice the lack of quotes, like. So let's say the table, in this case they think the table starts with A, and then we close the query and everything afterwards is a comment. It's false. Let's see if it starts with table users, still true, so we have a table name users, as they say here. Now the next one actually tries to guess the column name. So in this case, you're looking for information schema columns, where table schema SQLite 3 and table name users. So you're being very specific. You're looking into the table users and asking whether or not one of the column name starts with A. And column name is not ID. So you're guessing whether or not the column name starts with A and is not ID. Repeating this process will enable you to discover the column's ID, username, and password. So as you keep guessing, you find out that there's a column name username and a column name password, and of course there's a column name ID, which might be for the key of that table, for example. Thus, in this situation, once you have the logistics, once you have the name of the database, the name of the tables, and the name of the columns, you might want to guess what's inside the database by doing the exact brute forcing process, such as guessing, which is why I keep on emphasizing the fact that it's really important to actually know some programming in this case. Now you find out that there's a username admin and the password, and in this case you're guessing the password. Cycling through, now in a penetration testing situation you won't go this far, and not also in other situations in cybersecurity where you don't actually have to try to prove a point to get to own an entire system, unless you're in a very red teaming perspective. But when it comes to bare bones, when it comes to actual generic penetration testing circumstances, you won't have to go this far. You usually get the version of the username, the version of the database, which is a simple query, much more simple than this one. And once you get the version, you've proved your point that that application is vulnerable to SQL injection, and you've got your point cross all the way through. Now, you can now use the username and password 3845. So username admin 3845 to actually get the flag THM SQL Injection underscore 1093. Now notice, and I'm gonna say something here, notice that in this situation we have the same format, THM SQL Injection 9581, In this case, we have taim SQL injection, thm SQL injection 1093, and if there's any flag over here, we could just do the same brute forcing, because if you look at over here, you could just build a Python script and try to actually brute force. If there is a wrong answer here, you would actually try to brute force for the right one, and in this case it would be a guess of maybe 9,000 attempts, 9,999 attempts to actually guess the next flag over here, which I wouldn't encourage you to do, because that's actually, you're sending way too many requests to the server per unit of time. Alright, now blind SQL time based. Let's see how we are on time here. 15 minutes. Let's actually try and see if we can get this through. A time-based SQL injection is very similar to the above one, in the same that requests are sent, but there is no visual indicator if your query is being wrong or right. So no visual indication or either being wrong or right. This time your indicator of a correct query is based on the time the query takes to complete. So you're actually having a time delay, which is why you have a time delay between correct or incorrect query, which is why you're using the time delay by introducing a built-in method such as the sleep, a built-in SQL method alongside the union statement to actually see whether or not this actually works. So for example, now the mother of all is a blind based SQL injection, because you're doing everything in the blind. Admin 123 union select sleep 5. If it's gonna sleep for 5 seconds, so in this situation, where do we actually try to put it? Refer, try hack me, refer, let's say admin 123, get out of that, union select sleep. Let's see if it works with no caps. Sleep 5 to where database starts with username and it continues with whatever else is afterwards. Request time 3 seconds. Let's say if it starts with X, request 1, with A, request 1, with D, request 1. So there is no database that starts with this, but there is a database that starts with U. Union select sleep 5 to where database like U, D, US. Something's wrong here. Let's actually try to do union. Let's actually try to be thorough here. Union select 5 to word database like U%. Request time 0.1 second. Admin 123 union, of course, it's union select sleep 5 where database like this what is it that is wrong? Refer admin 123, close that, union select sleep 5 to where database like U%, then we close this. Request time 1. What is the final flag after completing level 4? What is it? You can now repeat the enumeration process from the Boolean-based SQL injection, adding the sleep method in the union select, which is exactly what we did. Let's actually copy this entire thing, and then can we actually paste it directly over here? Everything that's after the refer, and then we hit enter. It says it's okay. Request time sleep like 15. Doesn't seem to be working for some reason. What is the final flag after completing level 4? Let's actually look for a... do we have any walkthrough here? Write-ups. There are no submitted write-ups. So SQL injection write-up. Try hack me. I might be missing something, but I don't know what. And the point is not to waste valuable, precious time here. We're 21 minutes in, and I'm not actually trying to prove any point. So, is this what we're actually looking for? No, probably not, right? Where's the write-up? Yes, I'm very sure. Is that the flag actually? It's not the flag. This is not the room, very likely, is it? It is not. Let's look at this one from Motasem.
Welcome back.
And see what Motasem is doing. So he's got to the point where I got, and then he's got to the time-based. Let's look more over. So what was the query to get the request time of 5 seconds? Yeah, first you're trying to get, let's hear what Motasem has to say.
The same process. You look for a database name that whose first character starts with U. So database name actually directly it's SQL I4. So I type SQL I like that underscore 4. Now
That would be the database
5
name.
seconds to respond, which means there is actually a database whose first characters are SQLI.
Yeah, so good point. Let's actually see. So where database like S starts with S, sleep 5, SD 0, so SQLi now is starting to work. SQLi fall 4, So yeah, it seems to be jerking around. We're guessing the database SQLi4, and then let's see if it's the entire process of guessing, so forth until you reach the username and password.
As you can see, they turned okay after 5 seconds, which means, let me try anyway. Okay, how about 3? Let me do the fully wild, way easier.
So notice, once you get the database name, you're actually trying union select sleep from users, table users where username admin and password is. In this case, you're trying to guess the password.
Last number.
So password like 496.
6, 7. We tried 7. Injection master. Next thing.
What was it?
And you've got the final flag, the admin, and the password is 4961.
4961. So in this situation, let's go back, try our query, where union select from users. Let's try to build a query. Again. So thanks, Motasem. Union select 2 from users where username. Union select sleep 5 2 from users where username equals admin and password like password like. Password like 4960 496. Let's see what's the response that we get. .496, you get a OK. 4960, 4969, 4961. Sleep for 5 seconds and then you get it. So 4960, 001 seconds. 4961, sleep for 1, 2, 3, 4, 5, and then you get the response. So username admin, password 4961, and then you get the flag SQL Injection master. THM SQL Injection master, which is not something that I am. Alright, out of band SQLi. Maybe let's see how many minutes. 28. Let's actually try to finish with this one. Out of band SQL injection isn't as common as either the first two. Depends on specific features being enabled on the database server or the web application's business logic, which makes some kind of external network call based on the result from the SQL query. An out-of-band attack is classified by having two different communication channels, one to launch the attack, the other to gather the results. The attack channel could be a web request, and the data gathering channel could be a monitoring HTTP DNS request made to a service you control, such as, for example, Burp Collaborator. An attacker makes a request or other services such as Ngrok or other online services which are tailored to that purpose. An attacker makes a request to a website vulnerable to SQLi using an injection payload. The website makes a SQL query to the database, which also passes the hackers as payload. The payload contains a request which forces an HTTP request back to the interceptor. This is how it looks like. Name a protocol beginning with D that can be used to exfiltrate data from a database. Begins with D. DNS. Remediation. As impactful as SQLi vulnerabilities are, they aren't at the top of OWASP anymore. Developers do have a way to protect their web applications by using prepared statements or parameterized requests. Input validation, of course, can go a long way to protect what gets input into a SQL query, but you'll go a very long way with prepared statements. And of course, escaping user input, which is really important. You'd have to cut out input that contains characters like this one, which can cause SQL arrays to break, or even worse, open them for injection attacks. You'd really want not only to escape user input, but minimize output upon error. So escaping user input is the method of prepending a backslash to these characters, which then causes them to be parsed just as regular string and not special character. Name a method of protecting yourself from a SQL injection exploit. Is it a prepared statement? Right. So that's it with this room. We'll keep on our saga in the next video.